Oh, g'day again, guys. It's me. It's the 26th of October, just after lunch, and I've got a fair bit of data still that I've dug up, so I thought it might be worth making another video. And the company at the moment's very much concentrating on the drilling, and all their data sets will be, going through iterations of what the geology is doing at the end of those holes, but what we have here is, what I want to explore is really the nearology. What's the chance of finding another lens in this what would be classed now as a very prospective little bit of rock running down this way, and also we have this funny kink area here. This image is actually from August 2014, and it is a sandfire image. I mean, it's from the period after the JV, and all these blue holes are actually those 20 odd holes I said the downhole electromagnetic work was done in, but that's not really the focus here today. I'll just put in the discovery hole so you got an idea. There it is there, so that's more or less where Monty is. So what I want to do is just compare, see how this geology has actually evolved. Like the company's database will be very, very comprehensive, and they only give us regular folk, the most basic maps. But what we might be able to find something in these maps themselves. Now that's one of the later maps that we've got here, and you can see how there's a sort of more thinning in the geology. They've probably divided it a bit more intensely, but the main feature for our prospectivity, in terms of prospectivity, these two bounding faults, one here to the south, one here to the north, and because they're basically bounding our geology that along the strike of the rocks. Now, you've got to remember, I suppose at this point it's interesting to probably discuss a little the way these things form. And if you saw that 101 video on VMS deposits, it was brilliant, and it's really worth a watch. But the basic idea is you get these sulfides that accumulate on the seafloor. They're fed up through some sort of fault system. There's convection currents that circulate the salty seawater into the system as well. And so these will go on, I suppose, until the conditions inside under here allow it. Otherwise, if we get more volcanism, these things can be covered up by more volcanic flows, or even sediments that fall out of the ocean as a result of conditions under the ocean. So they can get snuffed out, but then they can also then reform at a higher level up here, and that's the case. In that case, you get these stacked lenses, so one on top of another. But those will be found by drilling. But the important thing is, if another rock formation is formed over the top of this, it's this boundary here between the younger one and the older one that gives our prospectivity for possibly another independently new deposit along here. So there's one here, there may be one forming further along somewhere. So this boundary is very important, and really that when these get thrust up over sort of 2 billion years to end up as these very old rocks in Western Australia, then they don't have much bearing any longer to this seafloor, but this boundary will still exist, and in essence the boundary is somewhere along here. So anywhere along this boundary could be another position for another lens. Now you can see here it's gone. This whole block here seems to have potentially rotated, or I don't know how it got there. I'm not a structural geologist, but it's almost at 90 degrees to the existing strike up here. So if I go back to the old geology, you can see that those two faults are more or less shown here in that little, see that little fault there going through there and then coming through here, and then the northern one you can see here, see where those volcanics are truncated there. So they're the two bounding faults, and then you've also got this other bounding fault where you've got these probably thicker but volcanic units, but they may just not be been have drilled to quite the extent, so they're probably less well understood. But there's another prospective zone all along here. Now, what I'd like to show you is the VTEM work that was done back in I think it was around April 2013, and that's a detailed inset. And then I should also have the the regional. So there's the regional picture. Now you can see there's at least 3 discrete VTEM anomalies. Now, if you don't know what a VTEM anomaly is, it's basically they're captured by flying these weird loops over the ground, and essentially they're measuring the electrical properties of the rocks. So something directly related to the sulfides, like their conductivity, resistivity, chargeability. Look, you don't have to really worry about it. But it's a direct measurement of the deposits they're looking for themselves. So if we go back, back in those days, they call this area the kink, and that's basically literally what it is, where the rocks have been kinked down. And let's see if I can't just go back to there's the detail. If we zoom in, can we get into the detail there? Let me see. I'm having a little problem here. Oh, I can zoom in with this. In any case, oops. So when you look in more detail, you've got probably like there's two little blobs here, 2 or 3 there, and then one sort of fairly prominent one there. So let's have a look. I'll just rectify this a little bit. It seems to have gone a bit out of kilter. Yeah, that's a little bit better. Now, if we fade that out, you can see that those anomalies are conforming more or less to this rock sequence here, and the other ones are sitting in this bigger zone here that I was talking about before. The other one's sort of sitting at the end of this point here, and just sort of in there. So they're all fairly interesting. Also, in that they've been drilled by Talisman, and you get quite a number of hits that are over 1,000 parts per million copper. So 1, 2, 3, 4, 5, 6. These are the sort of pink dots, and then the red dots are between 500 and 1,000 parts per million copper, which, if my maths is right, I think that's 1% copper but you might want to check that because I'm not quite sure of that. So, and the other point we've got to look at is, so this is interesting to me. This is not dead, because also when we look at where we're at with the ground-based surveys, you can see these blue squares have already been done this year by Sandfire, and these ones were the ones that were pending earlier in the year. So they're onto this. And I'll just see if I can fade that in and out to show you. All right, so that's sort of the edge of that. I don't know how far these loops penetrate our footprint, but they're definitely, I would have put a few more over here personally, but look, I find this kink area of a fair bit of interest, and we'll have to wait and see if it comes up. You see, you won't know until they've discovered something or get a result, because nil results are hardly ever mentioned in exploration announcements. So thanks very much.